Section 6.2, Systems of Equations. So in this section, we're going to continue with what we started in the last section, solving systems of equation. In the last section, we took a look at a system that had 2 equations and 2 unknowns. In this section, we're going to take a look at a system that has 3 unknowns, 4 unknowns, 5 unknowns, and so on. And again, the best way to solve a system that has large number of unknowns is by matrix elimination. Okay, and to do that, we first have to study something called a matrix. So let's do that. What is a matrix? A matrix is just a collection of numbers arranged in rows and columns. That's what a matrix is. It's just a collection of numbers that are arranged in rows and columns. So here's an example of a matrix. Usually you denote matrices with capital letters. You use square brackets. So you have 1, 2, 3, 4, 5, 6. This is a matrix. I have 2 rows. This is row 1, row 2. I have 3 columns, column 1, column 2, column 3. Okay, so this matrix has 2 rows and 3 columns. So we write it this way. We always write the number of rows first. So this is a 2 by 3 matrix. 2 by 3, 2 rows and 3 columns. You could also have matrices that are square. That means they have the same number of rows and columns. So you have 1, 2, 3, 4. So this is a 2 by 2 matrix since it has 2 rows and 2 columns. Okay, there's some matrices that are special. Okay, and the one that we need for this section, and that's the only one I'm going to talk about, is something called an identity matrix. An identity matrix is a square matrix. That means it has the same number of rows and columns. A square matrix with ones on the main diagonal and zeros everywhere else. So let's take a look at what we mean by that. So an identity matrix, I2, a 2 by 2 identity matrix. Remember, I2 basically means it has 2 rows and 2 columns because it has to be square. It has ones on the main diagonal. Main diagonal is the one always going down. So you have 1, 1, and it has zeros everywhere else. A 3 by 3 identity matrix would be something like this. You have ones on the main diagonal, and you have zeros in all other positions. So that's an identity matrix. Alright, so there's other types of matrices too. Okay, symmetric matrices and all kinds of other matrices, but for us we just need to know the identity matrix. So that's what a matrix is. It's basically just a collection of numbers arranged in rows and columns. It looks a lot like an Excel spreadsheet because that's what an Excel spreadsheet is. It has rows and columns. Okay, now we want to solve a system using matrices. So we need to be able to manipulate a matrix. So let's take a look at matrix operations. Matrix, and particularly we're going to take a look at row operations. We're going to perform operations on the rows. Okay. The reason why matrices are used to solve systems is because there's only very few things you can do with a matrix. Okay, and there's 3 things we can do with a matrix. The first thing we can do with a matrix row operation is we can swap rows. We can swap 2 rows. So I'll just do these by examples. So let's say that if I have a matrix like this, matrix A, I don't even need to label them. Let's just call it 1, minus 2, 4, and 5. And I want to swap the 2 rows. So I write it this way. You have to write down the command to do that. It's row 1 becomes row 2, and row 2 becomes row 1. The arrows indicate they're swapping. So in this case, all the entries in row 2 go in row 1 position, and all the entries in row 1 go into row 2 position. That's what we mean by swapping rows. Okay, the second thing we can do with a matrix is we can multiply a row by a scalar. A scalar, again, just a fancy word for constant. Okay, so here's an example of that. Let's say if I have 2, 3, 5 minus 1. Okay, and I want to make this, we want to change this to a 1. So what would I have to do? I would have to multiply that number by a half, because half of 2 is 1. So, but I can't just multiply one number. I have to always multiply the entire row, because these are row operations. Whatever we do to one thing in that row, we have to do it to all those items in that row. So this is how you write it. We're going to take 1/2 times row 1, and then that becomes row 1 again, because once we multiply row 1 by a half, all the numbers in row 1 have changed, so they have to go all those new numbers have to go somewhere, so we're going to put them back in row 1. Okay, so we have half of 2 is 1, half of 3 is 3 halves. Don't write decimals, please. So we get 1 minus 1. So the arrow indicates where those new numbers are going to go. So after I multiply row 1 by a half, I'm going to put them back in row 1. Okay, so that's a second operation, scalar multiplication. The last operation is row addition, where we can add 2 rows. Okay, so here's an example of that. Let's say if I have 1, 3 minus 1, negative 2. What I want to do is add row 1 and row 2. So I'm going to add row 1 plus row 2. Okay, and then whatever number I get, the result I get, I want to put it back. I can either put it back in row, I can put that result in row 1, or I can put that result in row 2. And the arrow indicates I want to put it in row 2. So I'm going to start by adding row 1 and row 2. The arrow also tells you which row you're changing. The arrow points to the row you're changing. Out here, I'm not changing row 1, so let's just copy that. So I'm going to take row 1 and row 2. So I take 1 plus minus 1 is 0. So we put that in row 2. I take 3 minus 2 is 1. We put that in row 2. Okay, so we add each element, and then whatever result we get, we put it back in row 2 in that column, whatever column that we were adding. Okay, and that's it. Those are the only 3 things you can do with a matrix in terms of operations. Okay, row operations. So we want to use these 3 basic things to solve big systems, 3 systems that have 3 unknowns, 4 unknowns, and so on. But before we go any further, let me just give you one final example of row operations. Let's say that I have a matrix like this. I have 1, 3, 2, 5. Okay, what I want to do is I want to make this 2 into a 0, sorry. Okay, so I can do some of these operations together, like these two especially. I can do them together. Okay, so I can do this. Since I want to make this 2 a 0, you always try to use the 1 in that column to do that. There's a 1 right here. Okay, so I'm going to take row 1 and I'm going to multiply that by negative 2. And so I'm taking row 1, multiplying it by negative 2, and I'm going to add it to row 2. Because to make 2 a 0, I'll have to add a negative 2. 2 minus 2 is 0. So I do that by taking row 1, multiply it by negative 2, and add it to that. And then whatever answer I get, I'm going to put it back into row 2. Okay, so let's take a look at it. I'm going to multiply 1 by negative 2, so I get negative 2, plus row 2, so I get 2. In this case, that'll give me 0. And the row 1 stays the same. So I multiply 3 by negative 2. 3 times negative 2 is negative 1. And then I add that to row 2. 3 by negative 2 is negative 6. You multiply 3 by negative 2, you get negative 6. Negative 6 plus 5 is negative 1. That goes in here. Okay, so you can perform multiple row operations together. Okay, now once you understand that, if you understand these 3 operations, you can really do some creative stuff when you're trying to solve a matrix. Okay, I'm sorry, trying to solve a system. Alright, so let's get started. Alright, so this would be C, solving a system of equations using matrix elimination. And this process, matrix elimination, is also referred to as the Gauss-Jordan elimination. Okay. Alright, so let's get started. So let's say if I have a system, I'm going to start by doing a simple example, then we'll move to a 3x3 and a 4x4 so you guys can see that. So I'll do the example we've been working with. X plus 2y is equal to 3. 4x plus 5y is equal to 6. Now, for small examples like this where you only have two unknowns, you'll notice matrix elimination might be a lot more work than you want, but you can still solve it, and you can take a look at how to do it. So the first thing I want to do here is I want to somehow take the system and put it into a matrix, and that's easy. All you do is write down the coefficient of your equations, just the coefficients. So we have one of your variables, 1, 2, and then you also write down the constant. Then we have 4, 5, and 6. And there's an equality here, so I'll denote that by a vertical bar. Okay, so this column here, the first column, represents all your x coefficient because you have 1x here, you have 4x here. And the second column represents your y variable. You have 2y, 2y, and 5y, 5y. And this is my constant. Do you guys follow? So if you were to, you can easily change it back. Once you get a matrix like this, you have 1x plus 2y is equal to 3. I have 4x plus 5y is equal to 6. This matrix is a special matrix. It's called the augmented matrix. And technically it's made up of two smaller matrices. It's made up of the coefficient matrix because these are the coefficients of my x and y terms, and it's made up of the constant matrix. So it's made up of two matrices, coefficient and a constant. So our goal is, this is our goal. What our goal is to change this augmented matrix, the coefficient matrix of the augmented matrix. This is my coefficient matrix, right? I want to change this augmented matrix so that it looks like this. I have an identity here. Identity looks like what? 1, 1 on the diagonal, zeros everywhere, and then some numbers here. Okay. So I want to somehow change this augmented matrix to this, where on the left I have the coefficient matrix and on the right I have just some numbers. Okay. On the left, I'm not a coefficient matrix, I'm sorry. On the left I have the identity matrix and on the right I have just some numbers. So that's what we do. We take a system, put it into a matrix, create the augmented matrix, and then somehow manipulate the augmented matrix using row operations. Those 3 row operations that we talked about. So you manipulate the augmented matrix using those row operations to convert it to a matrix that has an identity on the left and some numbers on the right. This is an identity that we talked about earlier, I2. Okay. So let's see how we do that. There's a method to the madness. What we do is we work, first of all, we work from left to right. Okay, work from left to right. Okay, and that, by that I mean columns, from left column to the right columns. Okay, the second step is, that's the first thing you need to understand. So here are the steps really. That's just telling you that we're going to go from left to right. We want the one, get the one in the column. Okay, so I'm working from left to right. So what I do is I go to the first column, I work from left to right. I go to the first column, get the one that I want. You know where you want the one because you want to change this to an identity. So I want the one in the upper left hand corner. So you get that one, make sure that that is a 1. Okay, get the 1 in the column 2. Use the 1. Okay, use the 1 to make all other entries in that column into zeros. Okay, so you use that 1 in that column to make into zeros. The next step is go to the after you get done, repeat steps 2 and 3 until all the columns are done. Until all the columns are done. So basically we work from left to right. What we do is, like for example, whatever I want to do, I want to change this to an identity, correct? So I already know where the 1 is. It's in the upper left hand column, so I get that 1 and then make all the other numbers in that column zeros. So I use that 1 to make this 4 as 0. Once I'm done with that column, make it look like this column, I go to the next column, get the 1. Then I want the 1 down here in the lower right hand corner. So I get that 1 and then use that to make everything else in that column a 0. Okay, so let's follow this game plan and see how to do this. Okay, so we always are working from left to right, and we keep doing this till we exhaust all the columns, till all the columns are done. And by done I mean they will look like the identity. Do you guys follow? So keep that in mind. That's what I mean by that. So here's the example. I have 1, 2, 3, 4, 5, 6. So I want to get the 1 first. I have the 1. And if you want, let's write down what we want to do, so that way we see exactly what we're trying to get to. That's not a bad idea to do. This is what I want to do. I want to perform row operations to change to that. So I want to get the 1 first. I want to get the 1 here. I have the 1. I'm done. I'm going to use that 1 to make everything in that column 0. So what should I multiply this 1 by? So when you add it to the 4, it'll become 0. -4. So you take -4 times row 1. You add that to row 2. That'll give us a new row 2. Okay, we're doing the scalar multiplication and row addition together. I'm multiplying the first row by -4, and then I'm adding that to row 2. The reason for that is because the only way I can make this a 0 is if I add a -4 to this, and the only way I can add a -4 is if I can multiply this 1 by -4 and add it to it. So let's do that. We're changing row 2, so I'm going to copy row 1 down. Whatever row is to the right of the arrow, that's what you're changing. So 1 times -4 is -4, plus 4 is 0. 2 times -4 is -8. -8 plus 5 is -3. 3 times -4 is -12. -12 plus 6 is -6. It is very vital that you take your time doing this, because it is so easy to make a mistake that it's important to do it step by step and make sure that you're not going to make any mistakes. Okay, even if you forget a sign, if you add wrong, you're pretty much done. So the key thing is, after you get done, always go back and check your answers. Please, it takes 2 seconds to do that. Check it to make sure you've done this correctly. Now that we are done with the first column, we made our first column look like our identity right there. So let's move on to the next column. Once we go to the next column, you always get the 1 first. Where do we want the 1 this time? In the lower right hand corner. So I want to make this -3 into a 1. So in this case, I'm going to take row 2 and multiply it by -1/3 to give us a new row 2, because my -3 times -1/3 will be just 1. Okay, so I get 1, 2, 3. So I get 0, 1, 2. Because -6, it's kind of multiplying by a scalar is the same thing as dividing. So you're really dividing the second row by -3. So -3 divided by -3 is 1. -6 divided by -3 is 2. Now that we are done with, we got the 1, you use that 1 to make everything in that column 0. So in this case, I want to make this 2 a 0. So what should I do? I should take -2 times row 2, add that to row 1, will give us a new row 1. Because I'm going to take this, multiply it by -2, and add it to this, because we always use the 1 to make things 0. So 1 times -2 is -2, plus 2 is 0. So that's what we are doing. And the new results go in row 1. So this time we're not changing row 2, so let's copy that. So 0 times negative 2 is 0. 0 plus 1 is still 1. 1 times negative 2 is negative 2, plus 2 is 0. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. So we got our identity. That's what we wanted. We got that. And we are done. Remember, this was the x column. This was the y column, correct? So what does this each row tell us? I have 1x. How many y's do I have? 0. So 1x, and vertical line stands for equality. So it tells me 1x is equal to negative 1. I have 0x, so I have no x. 1y, vertical line stands for equality, is equal to 2. So my solution is 1 and 2. Remember, we still want to write a solution as a point. So you can see with a 2 by 2 system, it was an overkill. We could have done this problem with elimination or substitution much faster, but the benefits of matrix elimination kick in when the problem gets bigger, when you have 3 unknowns, 4 unknowns, and so on. That's where it really benefits. So let's take a look at a bigger example. So let's say if I have a system like this. I have x minus 3y. Actually, let's pick a nicer one. I'm just trying to find a nicer system. X plus 2y minus 3z is equal to 0. We get 3x plus 7y minus 7z is equal to negative 4. And we get 5x plus 6y plus z is equal to negative 8. Okay, so here's a system that I want to solve using matrix elimination. Okay, so what do I want to do? First thing I want to do is put it into an augmented matrix. So let's do that. I have just write down all the numbers without the variables. I have 1, 2, negative 3, 0. I have 3, 7, negative 7, negative 4, 5, 6, 1, negative 8. Okay, so now what do we want to do? We want to change this. Always write down what you're trying to achieve. I want to change this left hand side here to an identity, so it'll look, it's a 3 by 3, so it'll be 1, 1, 0, 0, 0, 0, 0, 0, 0, and then we'll end up with some numbers here. Correct? That's what we want to do. We want to change the left hand side of the augmented matrix to an identity. Okay, so the first thing we always do is get the 1. In this case, we already have a 1. If we didn't have a 1, we would divide the first row by something or multiply by a scalar, same thing, to get that 1. So we have that 1. What do we do next? We use that 1 to make everything below it 0. And so please remember that. Get the 1 first always in the column, wherever the 1 is supposed to go in that column. And then you use that 1 to make all the other entries in that column into zeros. So in this case, I want to make this 3 and the 5 into a 0. So let's start with that. So what can I multiply this 1 by? And we always use that 1 to do that. Okay, I think I wrote that down right. Use the 1. Okay, so we always do that. So 1 times what should I multiply this 1 by? So when I add it to 3, it'll become a 0. It'll be negative 3. So you take negative 3 times row 1. You add that to row 2. Will give us a new row 2. And then I also want to make this 5 a 0. So what should I multiply this 1 by? So when I add it to the 5, it'll be 0. It'll be negative 5 times row 1. This time I'm going to add it to row 3. Will give us a new row 3. So let's do that. And sometimes this method gets really difficult when you start getting fractions. And so we'll see if we do in this case. Row 1 is not changing. So let's write it down. So 1 times negative 3 is negative 3 plus 3 is 0. 2 times negative 3 is negative 6. Negative 6 plus 7 is 1. Negative 3 times negative 3 is 9. 9 minus 7 is 2. 0 times negative 3 is 0. 0 minus 4 is just minus 4. Now we're going to do the same thing except with a negative 5. 1 times negative 5 is negative 5 plus 5 is 0. 2 times negative 5 is negative 10. Negative 10 plus 6 is negative 4. Negative 3 times negative 5 is positive 15, right? 15 plus 1 is 16. 0 times negative 5 is 0, and I get negative 8. By the way, the method that I gave you to do this is one way to do it. Once you get comfortable with it, you can figure out ways to take shortcuts. Okay, but for now, I just would like you to stay consistent with this method that I gave you up here. Okay. Alright, so we are done with the first column. It looks just like what we want, right? So we are done with this. So now let's move on to the next column. As soon as you go to the next column, you always get the one where you want. I want the one in the middle here. I already have that. That's lucky. So we're going to use that one to make everything in that column 0. So I want to make this a 0 and this a 0. So let's do that. We always use that 1. So what can I multiply this 1 by? So when I add it to the 2, it'll become 0. It'll be -2. -2 times row 2, because that 1 is in row 2, plus we're going to add it to row 1. That'll give us a new row 1, because I want to make that a 0. What can I multiply this 1 by? So when I add it to the -4, it'll become a 0. It'll be a positive 4, right? 4 times 1 is 4. 4 minus 4 is 0. So this 4 times row 2. You add that to row 3, will give us a new row 3. So let's take a look at that, how to do the rest. Okay. So I'm not changing row 2. Row 1 and row 2, 3 are changing, so always write down the row that's not changing, so you don't have to mess with it. So 0 times -2 is 0. 0 plus 1 is 1. 1 times -2 is -2 plus 2 is 0. 2 times -2 is -4. -4 plus -3 is -7. -4 times -2 is 8, positive 8. Positive 8 plus 0 is just 8. Okay. The next thing we want to do is multiply the second row by 4 and add it to the last row. So 0 times 4 is 0. 0 plus 0 is just 0. 4 times 1 is 4. 4 minus 4 is 0. 2 times 4 is 8. 8 plus 16 is 24. Okay. -4 times 4 is -16. -16 plus -8 is -24. Okay. So we are done with that column now. So we move on to the next column. So we are done with these two columns. As soon as we get to the next column, get the 1. We want the 1 in the lower right hand corner. So I want this to be a 1. So what can I do now? Anytime you want to make something into a 1, usually you always end up dividing. If you want to make something into a 0, you multiply by the appropriate thing and add it to that using the 1 in that column. So I'm going to divide row 3 by 24, or you can think of it as division, but the right terminology is scalar multiplication. You can think of multiplying by 1 over 24. Row 3 will give us a new row 3. Okay. Multiplying by 1 over 24 is the same thing as dividing row 3 by 24. So row 1 and row 2 are not changing, so let's copy them down. Zero multiplied by 1 over 24 is 0. 0 multiplied by 1 over 24 is 0. 24 multiplied by 1 over 24, the 24s will cancel, we get 1. -24 multiplied by 1 over 24 is -1. Now we use this one to make everything in that column into zeros, and that's the last step, and then we'll be done. So what can I multiply this 1 by to make this 7 a 0, -7 a 0? It will be 7. So 7 times row 3, you add that to row 1, will give us a new row 1. And what can I multiply this 1 by? So when I add it to the 2, it'll become a 0. It'll be -2 times row 3 plus row 2 will give us a new row 2. So we're changing row 1 and row 2. So row 3 stays the same. So let's just copy that 0, 0, 1, minus 1. So 0 times 7 is 0. Add that to 1 is just 1. 0 times 7 is 0. 0 plus 0 is 0. 1 times 7 is 7. 7 minus 7 is 0. -1 times 7 is -7. -7 plus 8 is 1. Okay. 0 times -2 is 0. Add that to 0 is 0. 0 times -2 is 0. 0 plus 1 is just 1. 1 times -2 is -2. -2 plus 2 is 0. -1 times -2 is +2. +2 plus -4 is -2. And that's it. We are done. remember what I said at the very beginning. If you remember when we started with the augmented matrix, this column here represents the coefficient of all the x variables, because what are the coefficients of x variables? 1, 3, 5, 1, 3, 5. This column represents the coefficients of y, and this the z. So if you think about it, we have the first equation tells me what? I have 1x, no y, no z, equal to 1. So x is equal to 1. 0x, 1y, 0z, so we get y is equal to -2 and z is equal to -1. Now wait a minute, what happened here? We got three values. In the last section and the previous problem we only got 2, x and y, but out here we got 3 because we had 3 unknowns, x, y and z. So how does that translate to lines and stuff? I mean, we said that in this case, oops, I erased this right there. In this case, this was the equation of a line, this was the equation of a line. So if we graph the two lines, the solution represented the point of intersection of the two lines. In this case, what does it represent? Because I have 3 unknowns here. This is actually a plane. Do you guys follow? And this is a plane. When you have 3 unknowns with degree 1, that creates a plane in 3 dimensions. So you're working in 3 dimensions. So it's something like this. I'm going to try to do my best to draw. So this is your x direction, your y direction, and your z direction. So you have something like this. You have a sheet of paper. A plane is just like a sheet of paper. That's like this. This is like your first plane. Then you could have another plane going like this. This could be a second plane. And then you could have a third plane, okay, that goes vertical. So all the planes, they intersect at a point. Do you guys follow? So they all intersect at a point, and that point of intersection is what you just found. Because you're in 3 dimensions, it has 3 values, x, y, and z. So if you cannot see it in this picture, just imagine, take 3 sheets of paper and then imagine you're crisscrossing them. They'll intersect at a point. Okay. Now it could also happen where they don't intersect. All 3 planes could be parallel. In that case, there's no point of intersection, so that system has no solution, just like before. Or it could be where 2 planes intersect. Okay, so they intersect at a line, and the third plane doesn't intersect either one, is parallel to one of these planes. So the other plane could be like this. These 2 planes are parallel, this one and this one, and then the third plane intersects the 2 of them. Let me draw a better picture of that. So here is the first plane. Okay, a plane is, like I said, a sheet of paper. Here's a second plane, and then I have a third plane that goes like this. So it intersects this plane right here along all of these points. It intersects this plane along all of these points. But it doesn't intersect all 3 at one point. So this would have no solution, because to have a solution, that point has to live on all 3 planes. All of these points, like for example, these points live on the blue plane and the yellow plane. These points live on the blue plane and the yellow plane. This is plane 1 and 2. Let me call this a green plane. So these points live on the green and the yellow plane. These ones live on the blue and the yellow plane. But there isn't a set of points that lives on all of them. So in this case, this would have no solution. So there's many different ways to get no solutions when you're working with planes as opposed to just lines. The only time you get no solution with a line is if the 2 lines are parallel. Okay, but basic, it's hard to visualize in 3D, but you can try to, or do that, or look in the book, in the notes, to see pictures of 3 planes intersecting. Okay, all right, so we took a look at one example. Let me do 2 more. Okay, 2 more examples and we'll be done with this section. So let's take a look at this example. We have x plus y is equal to 2. We have minus x plus 5y is minus 3z is equal to 4. And then we have 3x plus 5y minus z is equal to 3. Okay. Alright, so let's take a look at this. Again, as we have a system of 3 equations and 3 unknowns, and we want to solve this. Okay, so you want to find x, y, and z. That's what we are looking for. So let's change it to an augmented matrix first. So we have 1, 1. There's no z there, so we have a 0, 2. Then we have minus 1, 5, negative 3, 4, 3, 5, negative 1, 3. And I forgot to tell you the most important thing here. I think I mentioned it, but I should write this as a point, and I didn't do that. I started talking about the planes. 1, negative 2, minus 1. X, Y, Z. Once you get your solution, please take a minute and check it. Even if you don't want to check all 3 equations, at least check one of them. So check the last one. That's the easiest one. X is 1, Y is negative 2, and that. So let's check this one at least. You should check all 3, but if you're lazy to do that, at least make an effort to check the first one. X is 1, so we get 5 times 1. Y is negative 2, so you get 6 times negative 2. And Z is minus 1, so we get minus 1. And that should all equal to negative 8. So let's see. We have 5 minus 12 minus 1. Okay, so you get 5 minus 13 is negative 8. So we know that was the right answer. You should check all 3, but if you don't have time to check all 3, at least make sure you check the last one. Alright, so let's take a look at this. We want to do what? We want to change this to an identity on the left of the augmented matrix. So we have 1, 1, 1, zeros everywhere else. Would this be any different if we had 4 equations and 4 unknowns? No, in that case your identity would look like this. There would be another row out here. Do you guys follow? So just keep that in mind. It doesn't change much. The method still works exactly the same. That's kind of neat. Okay. Alright, so let's take a look at it. The first thing I want to do is get a 1 in the first column. I already have that in the right spot. I'm done. Use that 1 to make everything below it 0. So what can I multiply this 1 by? So when you add it to this negative 1, it'll be a 0. It'll just be 1. So 1 times row 1 plus row 2 will give us a new row 2. What can I multiply this 1 by? So when I add it to this 3, it'll become a 0. It'll be minus 3 times row 1 plus row 3 will be row 3. So we're changing row 2 and row 3, so let's copy row 1 down right away. Okay, so 1 times 1 is 1, 1 minus 1 is 0. 1 times 1 is 1, 1 plus 5 is 6. 0 times 1 is 0, 0 plus minus 3 is that. 2 times 1 is 2, 2 plus 4 is 6. Then we're going to multiply this by negative 3. Negative 3 times 1 is negative 3 plus 3 is 0. 1 times negative 3 is negative 3. Negative 3 plus 5 is 2. 0 times negative 3 is negative 3. 0 times negative 3 is 0. 0 plus negative 1 is negative 1. 2 times negative 3 is negative 6. Negative 6 plus 3 is negative 3. So we are done with the first column. Let's go to the next column. We want the 1 in the middle. So let's do that. Let's make that 6 a 1. So in this case, I'm going to have to do what? I'll have to multiply the second row by 1/6 or divide the second row by 6. So I take 1/6 times row 2 gives us a new row 2. Okay, so let's do that. I'm going to copy the first and the last row because those are the two that are not changing. We're only changing row 2. 0 times 1/6 is 0. 6 times 1/6 is 1. Negative 3 times 1/6. So you basically, like I said, think of it as dividing by 6. What is negative 3 divided by 6? Negative 1/2. So this time we're going to get fractions. So that's going to get ugly. 6 divided by 6 is 1. Okay, so we're done. We got that 1. So now we're going to use that 1 to make this a 0 and to make this a 0. So let's do that. So what should I multiply this 1 by? So when I add it to the first row, it'll be 0. It's negative 1. Negative 1 times row 2. You add that to row 1 will give us a new row 1. And then negative 2 times row 3. You add that to row 2. You add that to row 3. Will give us a new row 3. Okay, so we get 1 1 0 2. Oops, I'm sorry, I forgot to do that. I'm not changing row 2, wrong one. There we go. So 0 times negative 1 is 0, 0 plus 1 is 1. 1 times negative 1 is negative 1 plus 1 is 0. Minus a half times negative 1. It'll be a plus half plus 0 is just a half. 1 times negative 1 is negative 1 plus 2 is 1. Down here I get 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. So we take negative 2 times minus 1 half, and you're going to add it to negative 1. That's what we are doing. We are multiplying this by negative 2. That's what I did. And then we are adding that to negative 1. So the 2's will cancel. Negative and negative is a positive 1 plus minus 1. So you get 0. 1 times negative 2 is negative 2. Negative 2 plus negative 3 is negative 5. Now, at this stage, once you end up with something like this, you can stop, because even though I still have to make this a 0, but you know right away you have a problem, because can I make this a 1? No, because there's nothing I can do to make that a 1. Okay, so keep that in mind. And that's why we have to stop. But it's good that we have to stop because we know exactly what's going on. Because let's take a look at what we have so far, since we cannot make that a 1 because of the 0. I have 0x, 0y, 0z. So on the left I have 0. The vertical line stands for equal to negative 5. Is 0 equal to negative 5? No. So that tells me that this problem has no solution. Okay, so this problem has no solution, right? Now on the other hand, if we had 0 0 0 and this was a 0, then 0 is equal to 0 all the time. So then we have infinite solutions just like before, and then we'd have to find those, and I'll show you how to do that. Okay, alright, so let's take a look at an example where we have to do that, and this will be a last example. So we have 3x minus 5y plus 2z is equal to 4. We have x minus 3y plus 2z is equal to 4. We have 5x minus 11y plus 6z is equal to 12. Okay. Now, so I'm going to put that into a matrix. I have 3 minus 5, 2, 4, 1, negative 3, 2, 4, 5, negative 11, 6, 12. So I want to change this to an augmented matrix. I'm sorry, I want to change this to an identity to the left of this augmented matrix. I have 1, 1, 1, 0, 0, 0, 0. And we'll end up with some numbers here. Okay. So let's do this. So to change this to an augmented matrix, okay, the first thing we have to do is get the 1 in the upper left hand corner. So now you can be a little bit creative with this. Okay, do you guys follow? You don't always have to do this the hard way by dividing by 3 or multiplying by 1/3 to make that a 1. Because you see there's a 1 right here. So there was a row operation that tells me that I can swap these two rows. So that's what I'm going to start with. I'm going to take row 1 and swap that with row 2. So right away I don't have to worry about fractions. So if you can avoid fractions, try to avoid them. Sometimes, like I said, you just cannot, and you're just going to have to live with them. That's one thing. And again, I do want to stress this. These steps that I've given you sometimes make it a little bit longer to get to the solution, but they're systematic, so they'll always work. On the other hand, there are some shortcuts you can take to speed things up, but then it's not systematic. It depends upon the problem to problem. Okay. So now that I have the 1, I'm going to use that 1 to make everything below it 0. So I'm going to multiply this 1 by something. So when I add it to the 3, it'll be 0. So it's negative 3 times row 1. You add that to row 2, will give us a new row 2. Then you have negative 5 times row 1 plus row 3 will give us a new row 3. Okay. Alright. So row 1 is unaffected. So let's copy that down. I have 4. 1 times negative 3 is negative 3 plus 3 is 0. Negative 3 times negative 3 is positive 9. 9 minus 5 is 4. 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4. 4 times negative 3 is negative 12. Negative 12 plus 4 is negative 8. 5, negative 5 times 1 is negative 5 plus 5 is 0. Negative 3 times 5 is positive 15. 15 minus 11 is 4. 2 times 5, negative 5 is negative 10. Negative 10 plus 4 is negative 4. 4 times negative 5 is negative 20. Negative 20 plus 8 is negative 8. Okay? So now we have this. Okay. What do we do here? Well, we want to make that a 4 into a 1 now, so we can multiply by 1/4 R2. Gives us a new R2. Okay. Or you can already see what's happening. Okay. If I were to take this second row, multiply by negative 1 and add it to the third row, since they're identical, I would just get a row of all zeros, right? So why go through this extra step when you can just get the answer much quicker? So sometimes, like I said, you can take shortcuts and think about it a little bit. So I can do this. I can take negative 1 times row 2 and I can add it to row 3. Will give us a new row 3. Okay. So I get 1 minus 3, 2, 4. I get 0, 4, negative 4 minus 8. If you wanted to multiply the second row by 1/4 R2, and you could have done that, that would make this a 1, 1, 2. That's what would have happened, but you could have done that if you wanted to. Now what do? I multiply this by negative 1. 4 times negative 1 is negative 4, plus 4 is 0. Negative 4 times negative 1 is positive 4. Positive 4 minus 4 is 0, 0. Anytime you have a row of all zeros, you know we have infinite solutions, because this tells me how many x's do I have? 0. How many y's do I have? 0. How many z's do I have? 0. So this last row tells me I have 0 is equal to 0. Now, let's just say, for the sake of argument, you had a row of zeros like this. And this is where you had 4 minus 4, 8, negative 8. You always want that row of 0 at the very end. So do you guys follow? So if that happened, the next step, you wouldn't be done yet. You would have to swap these two rows. You always want all the row of zeros at the very end, at the very bottom, not at the very end, but at the very bottom. So that's what we had in our case here. So let's go back to that. We had 4 minus 4, negative 8. So we just lucked out that we had that way. So as soon as you know you have a row of zeros, you know you have infinite solutions, so you don't need to worry about these guys making these guys zeros. Do you guys follow? If you wanted to go through that much work, you could have, but you can stop right there. As soon as you have a row of zeros, or you have 0 equal to a number, you're done. You don't need to worry about the rest of the matrix then. Okay. So this last row, if you remember in the previous example here, we used like the first row to give us x, the second row gave us y, the third row gave us z. Since I have nothing in the third row here, okay, there's no way to calculate z. So I can go let z equal to a constant, since I cannot find it. Okay, what is the second row telling me then? I have 0x. How many y's do I have? 4y. So I have 4y minus 4z is equal to negative 8. That's what that second row is telling me. Is that okay? So that's what that second row is telling me. I know z is c, so I get 4y is equal to negative 8 plus 4c, because z is c, I'm replacing that, and divide everything by 4. So y is equal to negative 2 plus c. I'm dividing everything by 4. So now I know y. What's the first row telling us? Well, the first row is telling us that I have, I'll write it right here, I have 1x minus 3y plus 2z is equal to 4. So I get x minus 3 times y. Y is what? Negative 2 plus c. and z is what? C is equal to 4. So you get x minus 6 minus 3z plus 2c is equal to 4. C's, not z's. So you want to solve for x, move everything to one side. So you get negative 6 goes to the right, so you have a 4. 4 plus 6 is 10. And then this will give me negative 3 plus 2 is negative 1, and that goes to the side, so it'll be plus c. Okay, so there's your solution to that problem. Okay, so in this case we found the solution to be, make sure I did this right, oops, this should be a plus, right? Negative 3 minus 2 is positive, so this will be a negative 2. Okay, so my solution is x is negative 2 plus c, y is negative 2 plus c, and z is c. There's my infinite solutions, where c is just some real number. For every value of c we get a new point. For example, if c is 0, we get negative 2, negative 2, 0. If c is 1, we get minus 1, minus 1, 1, and so on. So you can get different points for different values of c. So that's how you do matrix elimination. Just definitely practice problems and then go back and check your work, and now once we plug in one value of c, if you want to check to see if this is the right answer, just pick some value of c and come up with a point. So we came up with this point, and let's see if it satisfies our equation. Negative 2, negative 2, 0. So let's go back up and check. So always, like I said, you need to check all of them, but at least let's check the last one just for the sake of time. So you have negative 2, x is negative 2, y is negative 2, and z is 0. So let's check. 5 times negative 2 is negative 10. Minus 11 times negative 2 is positive 22. Plus 0, because z is 0. You add these up, so you get positive 12, which is exactly what I have. So you know that works. Okay? So always go back and at least check your answers. And if you get infinite solution, the best way to check your answers, at least pick some value for c and do that. Okay?